Problem number 11. The figure represents a Carnot engine that works between the temperatures T1 equal to 500 Kelvin and T2 which is equal to 130 Kelvin, and drives a Carnot refrigerator that works between the temperatures T3 which is equal to 360 Kelvin and T4 which is equal to 200 Kelvin, and what is the ratio of Q3 over Q1. So let's we see the given figure. So what is given in this figure? You can see the first part of the diagram refers to the Carnot engine, and then the second part of the diagram refers to the Carnot refrigerator. So that means we are going to use two formulas here. So we have to use the efficiency of the Carnot engine, and also we have to use the coefficient of performance of the refrigerator. So let's we write the formula for Carnot engine, what we studied from chapter 20. So in chapter number 20, we studied the rule, the Carnot engine efficiency, which is given by work done over TH. And what is work done? TH minus TL or TC, anything you can use. So hot and cold. So or better I can use TC over TH. And if you want to write the same rule in terms of energy, we can write eta efficiency, which is equal to W over QH, which is equal to QH minus QC over QH. This is the formula for Carnot engine. And for the coefficient of performance, what formula we studied? K, which is equal to TC over TH minus TC, which is equal to TC over W. In terms of energy, you can write this rule as QC over QH minus QC, which is equal to QC over W. This is the rule what we studied from chapter 20. So now what you have to do, you have to apply these rules for the first set of the diagram. That means the left-hand part of the diagram, and we have to use this formula for the right side of the diagram. So in place of TH and TC, what I have to use? I have to use T1, T2. And in place of here, the right-hand side, for QC or TC over TH minus TL, I have to use T4 over T3 minus TC. T4 minus, T3 minus T4 I have to use here. So let's we apply this rule for this diagram. So better we can substitute the values of T1, T2 and T3, T4, all these things later. First of all, let's we apply the Carnot engine formula for this case. So how can I write? I can write the Carnot engine efficiency formula for this diagram. How we can write? I'm going to write this formula as T1 minus T2 over T1, which is equal to work done over, which is QH. So QH here is nothing but Q1. Clear? So from this, I'm going to rearrange this equation in terms of work done. So therefore, work done, which is equal to Q1 multiplied by T1 minus T2 over T1. So what I did here, you can see here, I will explain one more time. TH refers to T1. So you can see this is the hot reservoir, this is the cold reservoir, right? So the temperature hot reservoir here is T1. So that means TH takes the value of T1 according to the information given in the diagram. So likewise, TC, cold reservoir temperature here is T2. So over T1, which is equal to work done over energy, because highest energy, that means the energy in the hot reservoir here is Q1. So I just apply these values in this real formula. And after that, what I did, I rearranged this formula in terms of work done. So when you rearrange this Q1 will come here. So Q1 multiplied by T1 minus T2 over T1. So I just finished this formula for the Carnot engine. Now what I'm going to do, I'm going to apply the formula for Carnot refrigerator. That means the coefficient of performance. So all these refers to the efficiency. So let's rewrite the rule for the efficiency. How we can write the coefficient of performance here, which is equal to, so let's we see here, Tc over Th minus Tc. So this is Tc, this is Th. So how we can write? So here Tc is T4. So T4 over Th minus Tc. Th here is T3 minus T4, which is equal to Qc. Qc here is nothing but Q4 over. Clear? So that means here, what exactly they gave in this question? The Carnot engine drives Carnot refrigerator. So that means we have to incorporate the efficiency of the Carnot engine with the coefficient of performance of the refrigerator. So now what I'm going to do here, I have to write what is this W. This W tells about T3 minus T4, right? So W, which is equal to T3 minus T4. But in terms of energy, how we can write? I can write Q3 minus Q4, because Q3 minus Q4. Clear? So now from this equation, I'm going to rearrange this equation in terms of Q4. So therefore, Q4, which is equal to Q3 minus W. So now I'm going to take this Q4, I'm going to substitute here. Clear? So let's be substitute. So what we will get? K equal to T4 over T3 minus T4, which is equal to, in place of Q4, I have to use this. So Q3 minus W over W. So now we can split this part into two. So how we can write? I can write this part T4 over T3 minus T4. No need to write this coefficient because this is our coefficient of performance, all right? So no need to represent this K here. So now hereafter what I'm going to do, I'm going to use this K. I'm going to consider only this part. So T4 over T3 minus T4, which is equal to, how we can write? Q3 over W minus W over W. So that means this becomes 1. Clear? So now what I am going to do, this is our main equation. So you can see the Carnot engine work is going to drive the refrigerator. So what I am going to do, I am going to take this work, I am going to substitute this work here. So if you substitute, what you will get? So let's substitute the value first. T4 over T3 minus T4, which is equal to Q3 over, in place of W, I am going to substitute the entire term. So Q1 multiplied by T1 minus T2 over T1, and then one more minus 1 is there. So I have to write this minus 1. Clear? So generally, mathematical rule, this T1 will go to the top. So by that, this equation becomes T4 over T3 minus T4, which is equal to Q3 multiplied by T1 over Q1 multiplied T1 minus T2 minus 1. Clear? Now what I am going to do, I am going to keep this term here. I'm going to move this minus 1 to the left hand side. So by that, this minus 1 will take positive 1. That means plus 1. So I'm going to keep this term. I'm going to move only this to the left hand side. So when you just move this to here, it will take positive value. So by that, what you will get? Q3 T1 over Q1 T1 minus T2, which is equal to T4 over T3 minus T4, plus 1. Clear? So in the question, they ask you to find Q3. That means the ratio of Q3 over Q1 we have to find. So what I am going to do, I am going to keep this Q3, Q1 to the left hand side. I am going to move this T1 over T1 minus T2 to the right hand side. So let's see what will happen. So what I'm going to do, I'm going to keep only this Q, that means energy one side. I'm going to move the temperature other side. So what we will get, Q3 over Q1, which is equal to, this will go to the top. So T1 minus T2 over T1 inside the bracket, T4 over T3 minus T4 plus 1, because this term is common for both. That's the reason I just mentioned the bracket here. So right hand side I'm going to write T1 minus T2 over T1. Let's take the LCM here as T3 minus T4. By that what you will get, T4, and here you will get T3 minus T4. So plus T4 minus T4 get cancelled. Now you can see everything is in the multiplication form. This term multiplied by that term. So we got T1 minus T2 over T1 multiplication form. So T3 over T3 minus Q4. Left hand side we have Q3 over Q1. So you can see this term. If you want to rewrite this equation in another version, how we can write? We can write this equation as Q3 over Q1, which is equal to T1 minus T2 over T1 over, right? We can write T3 minus T4 over T3. You can see if you rearrange this equation, you will get this form. So I simply write this equation in this form. Why? Because we will get the answer easily. So when you rearrange this equation, you will get this form. So we just make our problem easy. So for that purpose, I am just rewrite this equation in this form. So because when you just rearrange these terms in terms of multiplication form, this T3 will come to the top, and this T3 minus T4 will come to the bottom. So it will again retake the same original form, right? So now what I'm going to do, I'm going to keep this equation. So Q3 over Q1, which is equal to, how we can write? I can write this as, I can split this form into two, right? So T1 over T1 minus T2 over T1 over, likewise here, T3 over T3 minus T4 over T3. So what you will get, this is equal to 1 minus T2 over T1 over 1 minus T4 over T3. Now I'm going to substitute the value of T1, T2, T3 and T4, which they already gave in the question. So you can see in the question, let's just go back to the question. T1 500, T2 130 Kelvin, and then T3 is 360, and then T4 is 200. So I'm going to substitute all these value here. So by that, let's see, we will get the answer for the ratio of Q3 over Q1. So let's substitute the value. 1 minus T2 value is 130 Kelvin over T1 value is 500 Kelvin over 1 minus T4 value is 200 and T3 value is 360. So we have to find the answer. So therefore Q3 over Q1, which is equal to 1.665. So if you want to write the answer in terms of 2-digit, you can just write, or you can just leave as it is. So this is the answer for this question. So the ratio of Q3 over Q1, which is equal to 1.665, or you can write 1.67. So this is the answer for this question. That's it. Thank you.